Uh, so, I will discuss the concept of loss functions, and which is nowadays becoming very important for trying to calculate any, make any decisions, whether multiple or in the sense single. How it is going to come, I am going to come to that later. And the corresponding utility based on this loss functions is also decently important, mainly in statistics, in decision sciences, in Bayesian analysis. Now it is coming for trying to find out the expected regret, expected loss, or expected positive benefit which you get. Based on that you do it. So, generally in any multi-credit decision making, the parameters can be either continuous or discrete. So, it is continuous or discrete, how you handle that I have discussed very briefly with the models for the artificial immune system, and how you can basically normalize them, scale them on a scale of 0 to 1, give weights, find out the weights using optimization, and then find out using AIS algorithms, and how you basically try to minimize the error of prediction. Now, in generally whenever you have any decisions to make, they, as if they are not subjective, or objectivity is definitely there, you obviously you have different tools to solve them. In case if they are subjective, you use some distance functions or loss functions. So, those loss functions are utilized in different methods. So, I will just very briefly go through the concept of scalar loss functions. They can be considered in the case of multivariate loss functions, multivariate utility, and you can basically do it accordingly. So, those class of problems where the decisions makers has in front of him or her a range of decisions based on which the range of alternatives are, you will try to basically combine them in different proportions to get the best set of decisions. So, the alternatives would basically give you the best benefit. So, MCDM, which is multi-criteria decision making, the technique, the decision variables can be either attribute or the continuous variables, and the variables can be discrete or continuous also, for which we will use either the normal distribution for the case when it is continuous, we can use the gamma distribution, we can use the exponential distribution, we can use the generalized Pareto distribution for the continuous case, and for the discrete case you can use the uniform discrete distribution, and all these things can be, or multivariate uniform distributions can be utilized accordingly. Now, the general classification based on this was done in the 1980s by Huang and Hun. There is a very classical paper which has got a huge number of literature survey or different areas in a very informal way which has been worked. They basically contributed in trying to bring all these under the same umbrella of trying to find out what are the different tools and techniques and the literature surveys in different areas we have them applied. Now, in multi-criteria evaluation or multi-criteria decision, whatever you have is basically you have an set of objective functions, and you want to basically try to given some constraints. So, constraints can be greater than, less than, whatever, you try to basically find out their optimum solutions. Now, whenever you are trying to find out the optimal solutions, if they are very subjective, you try to use the concept of utility functions. So, I will discuss the utility functions mainly from the scalar part, and obviously then the vector concept can be just extended accordingly. Now, the utility functions are basically the net worth of a decision making you are making. So, that can be the subjective in the sense my decisions can be different from yours or vice versa, or the collective decision for one person can be different from the collective decision from the second person, even if the age may be same, the income parity can be same, the decision matrix set can be same. So, they are basically some intrinsic characteristics based on which human beings take a decision. Now, whenever you are trying to take a decision, you basically try to use a concept of outranking. So, if the alternative A1 is better than A2, So, there are some best set criteria based on which you are trying to take that decision, or alternative A2 is better than A1. So, how do you analyze? So, generally the ranking system, when you try to find out the ranking or the overall score between A1 and A2 and A2 and A1 and form a matrix, if there are k number of such alternatives, they are not symmetric matrix. That means, the liking or disliking between A1 and A2 is not between what it should be between A2 and A1. So, if you are taking decision 1 and you are forced not to take decision 2 or vice versa, then the overall utility or net worth or the value which you are going to get in both the cases are different. So, it is not a symmetric matrix. So, that creates a problem, and the symmetric matrix also changes from person to person. So, if person 1 has a set of criteria or decisions for which the scales are positive, it may become that for the same set of alternatives or decisions, a person 2 can have a different set of points based on which, or the value based on which he or she will take the decision. Now, we will basically denote the consequences and the outcomes as a vector C. So, C would have different nomenclature, it can be C1, C2, C3 till Cn, and the corresponding alternatives would basically be given as A, which is also a vector starting with the alternatives as A1 to AM, M as in mango, N as in nose, which means that you will basically have a M cross N matrix based on which you are going to take a decision. So, these are some alternatives, some decisions, and it is basically a mapping which is happening between the decisions and the alternatives. And obviously, the utility function can be either scalar, that means between A1 to C2, or it can be basically in vector concept, you will basically get a vector of utility functions. Now, whenever you are trying to basically find out a utility, there would be some probability. So, choice, if there are choices, the probability would give you that what is the probability you will take a decision, and what is the probability, what is the outcome. Now, the outcomes are generally given by values, and these values accrues to you some points. So, that points can be in dollars, point can be in euros, point can be, say for example, in value, whatever it is. And based on that value, based on the dollars, based on the euros, based on the yens, you take a decision which basically favors you. So, what favors me would not be the same case as it is favoring you, or vice versa. So, obviously, there is a difference based on which we will go. Now, whenever you have a probability, there would be a distribution, and whenever there is a probability of distribution, there would be an alternative based on which you will basically assign some weights or wealths to that decision. So, what you want to do is that if there are weights or some values to which you are assigning a probability, you need to find out a so called average value. So, that average value is very simply the expected value. So, we will obviously follow a principle, you want to basically optimize or take the expected value to the highest level and try to basically minimize the overall variance. So, in many of the cases, it is considered that if you have a distribution which is complicated, you always try to maximize the odd moments, first moment, third moment, fifth moment, which are the corresponding, if you find out is mean, variance, skewness, kurtosis, you will go on. So, you will try to basically optimize or maximize the odd moments and try to minimize the even moments. So, to give a very simple example, whenever it is the expected value which is the odd moment, you will always try to maximize it. If it is the variance which is the second moment, you will try to basically minimize that. So, you use a different combinations based on which you will try to basically optimize these moments or optimize this output based on the fact that the actual function has a utility, that utility has some values, and those values have some probability, that is all. Now, generally, so let us consider this, these are very simple examples, hypothetical examples in order to make you understand. So, consider the outcome values are given, values are numbers, they are not assigned any units. So, if you consider the first column, these are the values, these are probabilities. Similarly, you have the outcomes B and the probabilities. How you find out the values, all these things I am going to come to that later. So, in reality, you want to take either out the decision A or decision B, obviously, you will basically place your bet on the case that what is the expected value. So, the expected value for both A and B in this case, it will be 15 into 1/3 plus 10 into 1/3 plus 15 into 1/3 for decision A, and for B it will be calculated accordingly, where both the values are 13.33. So, if I ask you that what will be your next course of action, you will try to basically minimize the variance. In some case it can be, say for example, you want to basically maximize the ratio of the expected value to the variance. In some of the cases it can be basically trying to minimize the ratio of the variance to the expected value. So, there can be different concept. Rather than take the variance, you can take basically the mod of the deviation, or that it can basically be the weighted deviations which you have, or it can basically be the variance with respect to the median. There can be different combinations based on which you can do. But generally when you try to find out the expected value and the variance is always found out with respect to the mean only, as per the general nomenclature. Now consider there are these are all simple examples to explain. Consider there is a game and team X and TYM are playing in two different tournaments. In tournament 1, the points 1, if there is a win, draw and loss, it is 2-1-0, which is the leftmost part which you are considering, this part. And in case 2 or in tournament 2, if you win, draw or lose, the points are 5-1-0. So, there are arbitrary, but with this arbitrary has some notion. So, in case 1 and case 2, team A has respective as 100 and 220 points, and team B has respective of 95 and 230 points. So, if you basically change the scenario, the ranking system or the decisions would change accordingly. So, what is good for case 1 for when you compare between team A and B, and what is good in case 2 for between team A and B again, are only specific to the example we are considering. So, it may change. So, you cannot basically compare apples and oranges. So, generally when you are taking the expected value of the utility, you try to basically find out the expected value. So, expected value is very simple. You find out the utility function and then basically multiply the number of proportions times it is occurring, which is basically coming from its probability distribution. So, it can be either discrete or it can be continuous. And in many of the cases, if the actual implicit probability of W is not known, you use different type of convoluted function or Jacobian transformation to basically find out what is the actual probability distribution of UW. So, say for example, you have, I am sure you must have done Jacobian transformation and all these things in class 12 or in engineering or in basic sciences. Given the distribution of x, if you want to find out the distribution of y, where y is a function of x, you can use different stage wise Jacobian to find out the distribution and do the calculations. So, when I am basically mentioning the distribution of W, it basically means that given the distribution of W, you will try to find out the Jacobian distribution. From that you will find out the distribution of UW and then do the calculation. That is very simple. So, if it is normal distribution, you do the Jacobian transformation and find out the distribution of UW. Like, let me give you an example. You are aware of standard normal distribution? So, if x is given, how do you convert x into z? You considered z as x minus mu divided by sigma. So, when you do that, it is a simple Jacobian you are doing. So, once you do that, you have basically the Jacobian transform function of f of z, which mean value is 0 and standard deviation is 1, which initial case for x was mean value was mu and standard deviation was sigma or variance was sigma square. So, we can use different Jacobian to find out these values. Now, here UW is a utility function which is the net worth which you are going to get. So, it can be scalar or vector. Based on that, you can basically try to find out how you are going to find out the net value. So, consider this very simple example. First alternative are like this. There are government treasury bills for which the actual value which you win, value is about 6 lakhs, and in the second outcome there are 3 trees. The probabilities are given as 0.2, 0.4, 0.4, the values are 10 lakhs, 5 lakhs and 1 lakhs. Now, these values are the amount of money which you are winning, but the net worth based on which you will take the decision is given by a utility function, where the utility function, if you notice, is given by the square root function. UW is equal to W to the power half, which means if I want to find out the expected value of this arm, so this utility will be what, square root of 6 lakhs. multiplied by what is the probability? Probability is 1. So, your expected value would be square root of 6 lakhs into 1. In the second case, if I have, so there are 3 arms. So, 3 arms probabilities are 0.2, 0.4, 0.4. So, for 0.2, the overall output which is going to come out is 10 lakhs. 10 lakhs would basically give me what utility? It would be the utility would be square root of 10 lakhs based on the utility function, and multiplied by 2. In the second arm, the probability is 0.4, and the corresponding value which I am getting is 5 lakhs. The utility will be square root of 5 lakhs multiplied by 0.4, and in the third arm, the overall value which I am getting, value which is kept on the table, but the net worth which is giving to me is not 1 lakh, it is basically square root of 1 lakh. 1 lakh multiplied by 0.4. So, if I want to find out the expected value, it will be square root of 6 lakhs of 10 lakhs multiplied by 0.2, square root of 5 lakhs multiplied by 0.4 plus square root of 1 lakh multiplied by 0.4. I find out the expected value and do my calculations accordingly. If another person comes, his or her utility is different, consider it, say for example, it is W square. So, in that case, what would be the utility of that person from decision 1? It will be square of 6 lakhs multiplied by 1. For the same person, for the second decision, it will be square of 10 lakhs multiplied by 0.2, square of 5 lakhs multiplied by 0.2, square of 1 lakh multiplied by 0.2. So, similarly, depending on the utility function, you can find it out. So, in this case, we find out the first alternative has a utility of 776, second has 609, hence the first alternative would be preferred, but that would be for the case for whom the utility function is square root of half. So, it can change from person to person. Now, general properties of utilities are very simple. So, there are 2. One is that more I give you, more you want, which means that the property of non-satiation, and this property of non-satiation will consider that is applicable for all the values of W I have. That means, the first derivative is positive, but there is a catch here. The first derivative is positive, but the first derivative will increase at an increasing rate, can increasing at a constant rate, and can increase at a decreasing rate. But du by dw is always positive, but the second derivative would change depending on the circumstances. So, and what are the circumstances? We will see that later on. So, the first property is that more I give you, more you want. It is not like the sweet example, the Rasgulla example we considered. So, the more money I give you, more utility I give you, more objective function value increases, you will always want that to increase. But that increase can happen on 3 counts. So, second derivative can be positive, second derivative can be 0, second derivative can be negative. So, based on that, which when we go, the human being can have basically 3 characteristics. I want to avoid risk, I want to basically be neutral to risk. Risk means the risk perception which I have. So, risk can have different notation, it can be in money form, it can be standard deviation form, it can be in mode of dispersion form, it can be weighted of variance of dispersion form, whatever it is. So, it can be risk averse, I avoid risk, I am indifferent to risk, and another one is basically I want to take risk. So, this is mathematically very written like this. So, if there are 2 events, one is the deterministic one, because that is why it is being multiplied by a probability of 1, and one is the probabilistic one. Only remember, in the probabilistic one, we will simply consider there are 2 arms, such that the probability sum of I1, which is arm 1, and I2, which is arm 2, the sum would always be 1. So, if I multiply the utility for arm 1 plus the utility of arm 2, what I have is basically the expected value of the non-deterministic case, and in the right hand side is basically the expected value of the deterministic case. So, if this is the equation, forget about the inequality, equality, or greater than type, less than type sign. Now, if I am risk averse, what I will do? I will always run away from risk. If I run away from risk, I will always go for the deterministic one. If I am indifferent, that means the overall value which I am going to get between the probabilistic and the deterministic one, it would be equal. And if I want to take the risk, I will always go for the decision where the the probabilistic outcome is coming. These are the scenarios for which if scenario 1 is given, 3 different sets of people will have 3 different connotations of the same problem. So, both of them are trying to make excess profit or positive profit, but the increase would happen in 3 different counts. So, one wants to love risk, take risk, one wants to avoid risk, and one is basically indifferent to risk. Now, in this case, if you have the risk averse person, so obviously the second derivative would be negative. I am running away from risk. If I am indifferent, that means whether is increasing and decreasing, it will happen at a constant rate. And if basically my second derivative is increasing, obviously I am a risk seeker. How? With a very simple graph I show it to you. So, marginal rates would be increases as a decreasing rate for a risk averse person. Marginal utility function is increases at a constant rate for a risk neutral person, and marginal rate is increasing at an increasing rate for a risk seeker person. So, see this graph. I do not want to love risk, so I want to avoid. So, see the dy dx is slowly going towards tan of 0 degrees. So, in that I am avoiding the risk. So, this is dy dx. So, but in general case it is increasing, but increasing at a decreasing rate, right. In the case if it is positive, it is neither positive nor negative, it will be a straight line. And in case if I want, it will increase. So, it is increasing at an increasing rate. So, in that first case d2y dx2 is negative, and the second case d2y dx2 is 0, and then third case d2y dx2 is positive. And in all the 3 cases dy dx is always positive, because the curves are increasing in all the 3 schemes. Now, I will just consider, so these are now decently heavily utilized in economics, in game theory, in some supply chain management trying to optimize. So, they are basically known as 2 risk measures or risk aversion factors. So, one is the absolute risk, one is the relative risk. So, absolute risk and relative risk, I will very simply state it like this. So, consider that you want to consider 2 examples. Number 1, you are doing relative grading and absolute grading. So, in relative grading, what it happens in 2 years, say for example 2 consecutive classes, the highest marks are say for example 70 and 80. So, relative grading, what you will do, I will basically peg that 70 to 100 and do the ranking for all the students in that class based on the fact that 70 has been pegged on to 100. So, what is the other marks for that class? In the case when the marks is highest is 80, what I will do, I will increase the 80 to 100 and do the actual final grading of that class based on the fact that 80 is now 100. In the other case, when it is absolute, I take the absolute marks as it is. So, if it is 80, I take it as 80, it is 70, I take it as 70. So, in the same way, in the concept of utilities, there are 2 ways how I can find out the concept of risk. One is the absolute risk measure and one is the relative risk measure. Absolute risk measure basically simply means that as my wealth increases, in the absolute sense, do I invest more or less in risky assets, that is all, in the absolute sense. And the relative sense, it means if my overall wealth increases, in the percentage term, does my overall investment in risky asset or investment in decisions which are risky increases or decreases. So, there is a huge literature review for that. The reason why it is given is that gives you a characteristics of the utility function, that is all. So, there are different derivations for that, for the scalar case, for the vector case. For the scalar case and the vector case, the concept used is very simple. You are aware of Taylor series expansion. So, in Taylor series expansion, what you do in a scalar form, you try to find out f of x minus f of x naught and basically expand that function in and around x naught. You take the first derivative and multiply it by h divided by 1 factorial. Then you take the second derivative multiply by h square, divide by factorial 2 and go continue till infinity. So, are you also aware of the multivariate form of Taylor series expansion? I am sure you are aware. So, in the first case when you take f of x, it is basically f of x being a vector, because x is a vector now. In the second term, which is basically the first derivative, it will be a partial derivative of that function with respect to all the variables which are there. So, if there are 3 variables, it will be del f by del x1, del f by del x2, and the third case it will be del f by del x3. So, those 3 would basically be the first term. In the second case, when you take the second derivative would be considered in this way. There will be 3 terms of del 2 f del x1, del 2 f del x2 and del 2 f del x3. Then there will be a combination of x1 x2, x2 x3 and x1 x3. That means, you will take del 2 f and then differentiate first with del x1, then with respect to del x2. The second term will be del 2 f, first you will differentiate with del x1 and then will del x3, and the last term, third term would be, you will find out del 2x and find out the differentiation partial derivative of del x2 and del x3. Now, you will consider them to be symmetric function, because we are considering the partial derivative of del x1 and then del x2 is exactly equal to del x2 and del x1. That means, the symmetric matrix holds. It is very simple. You just utilize the main concept which you utilize to find out this absolute risk function and the relative risk functions are simply Taylor series expansion. In the scalar case, in the case of multivariate case, and in many of the cases where you consider the random the x values to be random, you can use different random distributions to find out the Taylor series expansion. That is all. So, when you and the reason is why you need these 2 utility functions, the properties, I am going to come to that later. So, if it is risk aversion, risk neutrality and risk seeking, as I mentioned that it is risk aversion, the second derivative is less than 0, indifferent it is 0, and if it is basically risk seeking, it is basically greater than 0. Now, the actual derivation is this, but forget about all this derivation, you will basically have an absolute risk aversion property, and this is given here. So, if you pay attention to this denominator, this is always positive, because the first derivative is always positive, as I mentioned. So, the main characteristics of AW will depend on what is the second derivative property, whether it is positive, negative or 0. So, that will give you a property for the utility functions. Similarly, if you have the constant the relative risk aversion property, I will come to the relative risk aversion property. It basically means that you only multiply that with the wealth. So, wealth is always positive, because amount of money which you are getting is always positive. Hence, and there is a minus sign also. So, the sign which you have for the relative risk property, it depends on this only. That means, the second derivative of the utility function, because this the denominator is always positive, in the numerator w is always positive, minus sign does not change its characteristics from minus to plus. So, whatever is to be dictated is done by u double prime in both the cases. Why they are utilized, I will come to the later. These are scalar formulation, vector formations are also there, but only you have to remember that if you consider this concept of symmetricity, it becomes easy. If you do not consider the concept of symmetricity, it becomes a little bit complicated with, say for example, third to fourth terms. So, I will come to the okay. Now, in all the calculations which you do in general, there are only 4 utility functions. Mainly for your decision making, quadratic utility function is used. The reason is very simple, because quadratic utility function and normal distribution they go hand in hand. It means that for if the utility is quadratic, then be rest assured all the decisions based on which you are going to take the decision, the normal distribution always holds true, or vice versa. So, if it is normal, then the utility is quadratic. If it is quadratic, then the distribution based on which you are going to do your calculations is normal always. And normal distribution has a very fantastic property that if you add and subtract normal distribution, it always remains normal. That is the beauty of normal distribution. Logarithmic, exponential and power utility functions are utilized, but we will only very briefly say about all these 4 and why this relative and absolute risk aversion properties were important. I will very briefly mention them. So, this is the general way how the quadratic utility function looks. So, B is basically positive or negative depending on the situation which you have. So, if you find out the derivative of A means the function which you have derived or basically gone through, and you basically find out the first derivative of R also, then the quadratic utility function has these properties. Now, remember here, if B is positive or negative, whatever it is, both the numerator and the denominator is always positive here. So, in this case you can say that the absolute risk aversion property is always increasing here in the absolute sense, because it is always positive, and if B is positive, then the relative risk aversion property would also increase because this denominator is always positive. So, whatever sign B has, that will only dictate R prime, it cannot do anything to A prime, right. So, in order to give you a very simple example, you can do just in minutes using Excel sheet, you do not have to do any calculation. I just plotted few values. I took some W values, wrote down with certain B values, I took the UW values. Now, in order to find out AW and A prime, RW and R prime, what do? I first find out the difference of UW, that means the difference of 5.25 minus 3 is basically the delta W that you have, that is the rate of change of utility which is happening, divide by 3 minus 2, that means that will give me the rate of change of the utility function, which is the first derivative. Similarly, I can do the second derivative and find them out. So, the so called second and third column are not included here. I can find out U prime, I can find out U double prime. Once I find out, I can basically plug in these values. This is 2 minutes in Excel, and then you find out the RW value, so which you see is always negative, and similarly the A value which is always positive. So, based on that, you can double check the properties which have been stated here, they would be true, absolutely true. I plot them. If you can zoom, if it was possible, I could have seen. You see the quadratic utility function looks like a quadratic curve, and if you remember, and if you take it to the negative side also, it is basically a curved function, which is parabola, which is the variance curve which you have. And similarly, I have tried to find out A prime, R and R prime. So, the color schemes are given as yellow, light blue, violet and so on and so forth. If I do the logarithmic one, again you do the same thing, differentiate and then find out U prime, differentiate, find out U double prime, put it in the equation, find out A, find out R, then again differentiate A and R, you find out A prime and R prime, these values are there. As W is always positive with a minus sign, A prime is always negative and R is always 0, because if you differentiate and all these things, they come out to be this. So, again I take up the same set, find out the values and just check the value of A prime is coming out to be negative, while the value of R prime as it should be comes out to be 0. You can just double check that. So, I plotted that. This looks like a logarithmic function, the pink one means the one which is in front of you, this one, and these are the A prime, R prime, the blue, the yellow, light blue or greenish blue, violet and the dark brown colors which are there. Similarly, I do have the exponential utility functions. The exponential utility functions are used for projective valuations in generally. So, where the returns are exponentially increasing or exponentially decreasing due to depreciation. For big projects, for decision making has to be made in a big way. So, you can find down them, again you put U prime, U double prime, put it and find out A prime, R prime, the values comes out to be 0 and A. A is a constant, the value which you have taken. Similarly, you do the exponential utility function, plot it and if you again plot it the value. So, if you see r prime value comes out to be exactly constant as it is, which is the value of a which I found out. So, if you plot them, the values of the utility function, their values of a prime, r prime are exactly like this. So, this is the utility function which you had. Finally, the power utility function, you take any value of c, differentiate, find out r prime is 0, and if c is greater than 1, then a prime is positive, if c is less than 1, it is negative. So, you can take any values accordingly, same set of values, find out u prime, u w prime, a prime, r prime, check them. The r prime values comes out to be 0, plot them, and you can basically do your calc. Just for information, you can find it out, they come out to be as it is. So, this is 0 as you find out r prime. Now, in generally whenever you are doing any very simple case of stochastic programming, many of the cases the distributions may be given. So, if the distributions are given, what is the best way you need to do is that try to fit the stochastic value with their expected value, and based on the expected value you try to do your calculations and find out the expected value of that variables, and then do your calculations accordingly. So, a similar concept is utilized in utility which is known as a certainty value. Certainty value is very simple. Certainty value is that value in what rupees, dollars, yens, whatever it is, which will give you the same value of the expected net worth of the decision based on the fact that the probability is 1, such that the expected value matches the non-deterministic decision. So, in this problem, if you considered that in the problem when there was only one decision of 5 lakhs, and there were 3 decisions of 10 lakhs, 5 lakhs and 1 lakhs, the actual value based on which you will be indifferent between the probabilistic one and the deterministic one is basically the certainty value, that is all. So, certain value would basically make your decision indifferent between the probabilistic one and the deterministic one. So, if you consider any decision, the certainty value will give you an expected value which will exactly match the probabilistic one. So, if you remember the example here, and just consider this example. So, consider the first alternative is not there, you want to find out the certainty value for the second decision. So, what is the expected value of the second decision? It is basically 10 lakhs, square root of 10 lakhs into 0.2 plus square root of 5 lakhs into 0.4 plus square root of 1 lakh into 0.4. So, that will give you a fixed value. So, what you will do is that you will find a value of C such that the expected of value of C exactly matches this probabilistic distribution. So, consider C is the net worth, but what is the overall expected value of C? C has to be found out in terms of its utility. So, the utility of C would be what? Square root of C. Square root of C multiplied by 1 is its expected value. That should exactly match the probabilistic decision which you are going to take. So, in this case, when you are trying to find out, the decision will be like this. Say for example, there are 4 arms and the probabilities are P1, P2, P3, P4. The utility I am writing for the time being as u, whatever the function of u is. So, it will be u w1, u w2, u w3 and u w4. So, u function will change from person to person. So, once I find out the expected value, what do? I multiply these values and add them up. Right. So, once when I am finding the certainty value, it is that value of C such that u of C into 1 should be exactly the same. So, given the expected value of the decision, I can find out that C, because the utility function will be the same in both the cases, and plug in that value C, find out that value C, that will make me indifferent between the certainty value, which is the deterministic case, and the non-deterministic case. That is all. Yes, it has to be any of the 4. Any of the 4, they cannot be anything else, but there is a methodology how you do that. Some concepts are estimation, some concepts are basically you forecast, and so on and so forth. So, there is concept where I ask you questions, and based on that once you give me the answer, based on that I take a decision what type class of distribution you would be having. Generally yes, and there is one which is known as the hyperbolic absolute relative risk aversion property, which is Hara. Hara has different forms which are only on one of these 4. So, Hara is used in a very general case when you want to find out the expected value of a decision, or find out Hara has its own vector component also, where you can find out the expected value of Hara and can do the calculations accordingly. Okay. So, there is a methodology like this. Say for example, I assume that it's like this, even though it's not in the slide, I'll just basically. So, consider I play a game with you. I'll tell you. I play a game with you, and on the table there are 2 values. So, that value I decide, and there is a coin. So, coin is actually an unbiased coin, half and half. So, and okay, I have not drawn this also. And then I ask you that, and on the other hand of the table I place some amount, arbitrary amount, and that is fixed in the sense that does not have any probability. So, I ask you a question that would you play this gamble, or would you take this constant value C, right. Now, I have already intrinsically I have drawn a 45 degrees line. Now, if the probability of getting an head and tail is half, then what is the expected value based on the fact that the utility is W. So, A would have an utility for me, which I am assuming for you would be A only, and B would have a utility which is B only, because I am considering the utility as a linear function. So, the expected value of that decision would be what? A into half plus B into half. So, if I think you are equivalent to this gamble, then the C value at which you will take the decision would be exactly equal to A into half into B into half. If you take that, if you are indifferent between that C value, and if you are indifferent between the C value and the gamble, it means what? You are equating them in the same scale. What is the value of C? C value is C only, because as per the utility. And what is the utility of that A and B decision? It is A into half plus B into half, right. Say for example, you take that gamble, which means the overall net expected value of that gamble is higher than C. So, if it is higher than C, what will happen? For your case, the midpoint of this is the expected value. You draw a vertical up, and if you basically draw a horizontal also onto the left, so this value which is the midpoint, they balance. Any value up or low would give me an indication whether you like the risk or avoid the risk.
Sir, I am trying to relate this concept with the non-dominated solutions that we determine with the help of optimization algorithm. We have set of non-dominated sets. That is also a
right.
MCDM.
Right.
In that case, how to decide what utility function to use?
See, everything cannot be basically spoon feed. You have to basically take a decision based on the situation you are trying to solve. Utility function which you are going to use, that will be specific to the decisions. For finance, I can say that, say for example, you will take a utility function is either quadratic or logarithmic. For decision making, when you are taking the projects or decisions where you have to build a factory, where basically for facility location, I know that you will try to take the power utility function. That will be dependent on the type of problem you are trying to do. For that, you have to basically do a huge amount of literature survey. Nobody can spoon feed you. The reason I am saying is that I am basically getting many questions that how you have solved the problem. I am not going to spoon feed on how you solve the problem. You have to burn your own fingers.
Okay, right, sir. We will figure it out. But are we expected to give each solution set equal probability? Like
Not necessarily. Why should you give equal probability to all? And I am just diverting from the discussions. I have a very strong feeling, and I am not saying that it is only true for you, it is true for all the students. Your main aim, and correct me if I am wrong, and I am sorry if I am right, your always aim is basically to check at the end goal without looking at what methodology you are trying to utilize. Paper publication and all these things are fine, but basically trying to look at the main aim, what you want to do, rather than learning the process is absolutely of no use for you. Then do not waste your time here. PhD work, MTech work, something is nothing to do only with paper publication, is basically to expand your mindset and basically expand your thought process. Nobody can spoon feed all those things. You have to burn your fingers, do it. You have to do it, or else no, not even God, or not definitely not your PhD thesis guide will help you. This I am saying with a little from the fact that these questions I always face. It's not that I was absolutely, I was also in the same state, but you have to be adventurous. If you are not willing to experiment, it is not going to help. Read a lot, and don't only read only your textbook. Read other story books also. I am sure you do not do that. Okay, coming back to this, I am assuming this is a linear function. So, based on the linear function, I want to categorize in what category you are. So, either you can love risk, hate risk, or you can be indifferent. If you are indifferent, what does your concept say? It will be along the straight line. If you love risk or hate risk, it will be on the top or the bottom. That is all. There cannot be anything outside this whole three different these sets. So, for you, if I start asking you questions, you will either take the risk, be indifferent, or basically avoid the risk. So, if you are indifferent, you are definitely on the straight line. If you hate or take the risk, you would be in either portion of the curve, which is above or below. So, if I keep asking questions and you always either hate or avoid or basically love the risk, your set of points would be either of this type or of this type. There cannot be anything out. So, it is either convex or concave. If it is concave and convex or concave, your utility function is always increasing, but increasing at an increasing rate, increasing at a constant rate, increasing at decreasing rate. So, the curve will go like this, or will go like this, or will be a straight line. Can there be anything outside? It cannot be. And then you do different type of parametric estimation to find out the parameters of this utility function, that is all. And the characteristics of the utility function is already stated here. The first two bullet points. So, if they are there, they are quadratic. The first two bullet points, if they are there, then logarithmic. This is exponential and this is power. Anyway, so here what you do is that if my utility changes, the certain value will change. If I am buying a LIC this the issue or a stock, or I am buying a health insurance, or basically buying a car insurance, the premium paid by each of us will be different, because we have different risk perception. The company has different risk perceptions for us. So, for us it will be the health for the health insurance, whatever disease we have, what is the age, what the hereditary disease, and so on and so forth. For car it will be the age of the car, what is the depreciation value, what is the make of the car, whether the car has met with the accidents, and so on and so forth. So, there are different ways of trying to basically analyze the risk perceptions. So, if you do the first problem and you find out, suppose you have two options, utility functions are given. In option 1 you toss a coin, if a head comes you win 10, if a tail comes you win 0. Thus, the expected value if you find out using the quadratic utility function will be 3, and if you want to find out the certainty value, you just map it, the expected value of the decision which is probabilistic, map it with the case which is the certainty value, and then find that out. So, if you take that value C, you are indifferent. If you want higher than C, that means you want to basically avoid risk. If you want lower than C, you want to basically take the risk. So, for venture capital problem which we did, it will be different depending on the cases. For the venture capital, whether utility function was square root of W. So, in probabilistic and deterministic one, actual aim is to find out the expected value, and you can utility function has, depending on the case, generally they are linearly additive. So, you have different type of expected values for different objective function, you can just find out the addition and basically or weight them, give some weightages depending on what you think is important, and then can solve the problems accordingly. So, in many of the cases you have either the expected utility maximization is there, or risk aversion basically means you want to minimize the risk of the variance which is respect to the utility function. So, generally for mean values, in many of the cases we see that trying to find out the expected value of the mean may not give you the right answer. So, say for example, you are aware of the concept of geometric mean, harmonic mean, and arithmetic mean. So, arithmetic mean would be used when I am trying to find out the average weight, average height. Geometric mean would be used when I am trying to do something with respect to the rate of change of the investment which I am doing in the bank. And harmonic mean would be the use case, say for example, when I want to find out the average speed of a car traveling from city A to city B and city B back to city A. So, there are different concepts how you can use the mean values. So, obviously, the mean values would have a corresponding different values of variance also calculation. So, in that case the mean becomes the arithmetic mean, harmonic mean, and the geometric mean. Now, in generally we see that when you are trying to maximize, you will use the maximum of that particular mean, or when you are trying to minimize, you will take the minimization of that variance and do the calculations accordingly. Now, in the geometric mean or the safety first criteria is basically you always want to avoid the risk. Try to basically increase your utility and increase your net worth, increase the actual value objective function, and in the other case when you are taking the negative side of that, you always want to basically make it as low as possible. So, I will show you in a graph which will basically make sense. Okay. Now, in the safety first principle is you always will try to basically consider that you have, I will try to draw it in order to make you understand. I am drawing a normal distribution only, it can change depending on the distribution. So, there are two ways how you do the safety first principle. In one case, you keep a value of RL fixed and try to basically find out the expected value of the distribution or some quantile of this distribution as far as possible from this fixed value of RL, which means you will try to maximize the distance between the RP or the average value of R and the RL, go as far as possible. And another case is that where you cannot increase the expected value, you try to push RL as far as to the right as possible, which means as you are pushing up RL, the average value RP will also start shifting onto the R, which means that you are increasing the lower level values, making them higher and higher. That means you are considering the real line, values onto the left are negative, values on the right are positive. So, you will try to basically push RL by maximizing RL in such a way that the average value also starts increasing. So, that will depend on the case when you are not aware of the expected value, you assume that to be within a certain band and basically try to maximize RL such that the expected value also increases. So, obviously, you put as a constraint or an objective function will depend on the problems you are trying to solve. And in this case, you use something just for the information I am stating, you use some sort of reliability programming. In reliability programming, the concept is very simple, whatever the distribution is. In the reliability programming, generally we try to find out that what is the reliability of a particular distribution and what is the reliability of a certain value exceeding that RL. Based on that, you will try to basically do the formulation. So, in this case, in reliability programming, generally there can be two flavors. One is that there is a reliability of the probabilistic part on the objective function, but in main cases the reliability is on the subject to constraints. So, subject to constraints are basically done like this. You basically have some maximization problem or minimization problem, whatever it is, and consider the constraints as, I am just drawing one of the constraints, is basically less than equal to, say for example, A1. It can be greater than, less than, equal to whatever. In reliability optimization, reliability programming case, we consider this as greater than equal to some beta 1 and then convert them using the concept of central limit theorem to a normal distribution. Once you convert them to a normal distribution, what happens? This will become probability of G1x minus its expected value divided by its variance less than equal to A1 minus the expected value of G1 divided by its standard deviation. So, it basically gets converted to a normal case. Use simulation in order to find out what is the probability that you will get those values greater than beta 1. So, this beta 1 would be dependent on your case. So, how better or worse your results would basically depend on what is your overall level of risk or level of competence you want for the overall simulation. So, higher the value of beta, more number of simulations you have to do, less the number of beta, less the number of simulations you have to do. So, you can utilize that in order to basically generate the data, generate the constraint region and then basically optimize it accordingly. So, these are generally used for design problems, and these is one of initially for the last 5 years or 6 years they are being very heavily used in mechanical design, in electrical design, in finance, in civil engineering for laminar and viscous flows, so on and so forth. So, with this I will just close it here, and any questions if you have related to the course or whatever, I will try to answer that. And another thing which I absolutely agree, that you may not agree with me now, but do not look at the problem. I am not talking from the perspective of the course. Do not look at a problem only at the end solution. There is a lot of learning tools in between. If you think of a problem only trying to basically blindly follow a path, that is not going to give you the results. Even you may not be absolutely able to solve that problem, there is no problem in that, but at least give it a try, so that your learning process gives much more in-depth analysis. Trying to finish in a shorter duration time is not the rule of the game. It does not happen, because I keep hearing questions. I did hear in many of the discussions in the last week that how I am going to solve that problem, that nobody is going to spoon feed you. Forget about that. At least do not expect such answers from me. It does not happen. You have to burn your own fingers, do the work on your own part so that you are able to solve the problems accordingly. Okay, if there is a class, I will just end it here, and thank you very much for your attention. Thank you.
Sir, I just asked
No, no, I absolutely understand.
to get a direction.
I absolutely
Expecting that you will be telling. I thought there may be
see.
some
See,
methodology to find
this whole set of class, I agree that crashing these 5 days is impossible to learn, right? It's basically to at least understand. So, there may be many methods which somebody has done, somebody may not have done, some words have been mentioned. Basically, you pick it as a cue to do that. I am not saying that, no, absolutely not. I am not saying to you, I am saying in general this is the trend, and that is what is making me nervous. I am not saying only you, it could have been my PhD students. I tell them to all, do not think your work as a shortcut method. If you do that, you are dead.
being a teacher, I was expecting some direction.
No, that's a problem.
You may set
No, nobody is going to give you the direction. Trust me. If unfortunately in India,
teaching the same thing.
I don't give any direction to my students. No, absolutely not.
I was thinking like
That is the problem which is happening. Nobody is going to give you direction. You can bug, you have to sit down and basically burn your midnight lamp, burn your fingers until unless that is happening. Nobody is going to help you. The whole scenario has changed because unfortunately in our India, our basic education, and that's we are to be blamed for secondary and primary education. They have killed the education system. Nobody is willing to think. None of you read any books in your mother tongue, and guarantee that. You don't read that. You don't read, absolutely don't read. You don't read any storybooks. It's my same case with my son. They are not willing to read any storybooks. Everything is there on the none of, I said that I don't write emails. There's a reason for that. You either you will do, I'm not criticizing anybody. You either do WhatsApp or you do Facebooking. Nothing else. You would not write letters. You would not talk with your friends. You talk with the friends over the phone calls.
sir, I'm sorry if I
No, it's nothing. It's nothing to. This is I am finding, and trust me that I have, fortunate or unfortunate, I have about 15 years of experience. I know the more you basically push yourself, the returns may not be immediately high, but trust me, they will be positive.
sir, I could have get answer like that's on you to figure it out.
That's what I was going to say. What is it?